Hello. In this EdpHroom statistics video, we're going to focus on the p-value. The p-value, or the probability value, is a measure of the strength of evidence. It's not a test, as many people sometimes mistake it to be. Instead, it is simply a measure of probability. And in fact, it can be derived from many different statistical tests. In order to properly understand the p-value, you also need to understand what the null hypothesis is. The null hypothesis is a statistical concept. It states that whatever the difference observed between the arms of an experiment, then that difference is just due to random chance, rather than caused by the intervention, whether that intervention be a new drug or something else entirely. If it is possible to reject the null hypothesis, then it can be said that there is a causal relationship between the intervention and the results, i.e. the intervention actually does have a real effect, such as a drug actually causing lower blood pressure across a population. But how do you decide whether you have enough certainty to reject the null hypothesis or not? This is where the p-value comes in. The p-value is the probability of an observed difference between the effects of different interventions or treatments being due to chance alone, and it can take any value between 0 and 1.0. Going back to the concept of the null hypothesis, if the p-value is found to be 1, that would mean that there is 100% evidence for the null hypothesis. In other words, that it is absolutely certain that any difference between the results in the different arms of the experiment are due to chance and not due to the effects of the intervention. Alternatively, if the p-value was 0, that would mean that there is no evidence for the null hypothesis, and thus it is completely certain that the observed differences in the different arms of the experiment are due to the effects of the intervention and not chance. In reality, absolute certainty doesn't exist. So it's been decided that if the p-value is less than 0.05, then the results of the experiment are declared to be statistically significant, and this is considered enough to reject the null hypothesis and to declare the results observed between the different arms of the experiment are due to the intervention and not chance alone. The decision to say that a p-value of less than 0.05 is statistically significant is to an extent arbitrary, and as you may have realized, a p-value of 0.05 indicates that there is still a 5% probability that the observed difference is due to chance. But it is the convention that this value is considered enough to dismiss the null hypothesis and declare the intervention has an effect. To summarize, the p-value is not a test, but it is a measure of the strength of evidence. It has a value between 0 and 1.0, and if the p-value were 0, that would mean that you could reject the null hypothesis and say that the intervention in the experiment has had an effect with 100% certainty. In reality, this level of certainty doesn't exist, so it's been decided that a p-value of less than 0.05 is enough to say that the results of an experiment are statistically significant. Thank you for watching. Please do post your comments or questions below, and I'll do my best to respond to them. Please also click subscribe for further videos.